Hello, everyone, and welcome to the January online viewing session for the Kalamazoo Astronomical Society. My name is Richard Bell. I am president of the Kalamazoo Astronomical Society, and I will once again be your host for this evening. So it is great to have you here. We had 240 some odd people register, and we're approaching roughly 80 people here on Zoom. And we've roughly got about five or so people on YouTube. I will try to pay attention to those of you watching on YouTube out there in case you have any questions. And in case anyone here has any questions, you can put that in the chat. I will let you unmute yourself here very soon. But for the time being, let's go ahead and get going. So I'm going to share the screen again here, and we'll go right back to the opening slide that you saw. And for those of you joining us for the first time, this image here shows the Chiricahua Mountains with Cave Creek Canyon. And this is the observatory where the Kalamazoo Astronomical Society Remote Telescope is located. So we can take a closer look at that, and here it is. So this is Piishi Observatory, which is Apache for Nighthawk. So basically Nighthawk Observatory, but to keep the local flavor, we call it Piishi Observatory. And it's a 20 by 20 roll-off roof observatory, a bit bigger version than what we have at the Kalamazoo Nature Center with Owl Observatory. But in this observatory here are four telescopes, three of which are owned by Mike Patton, who also owns the property and the observatory. But one of the telescopes is ours, and you can just see it poking its little self above the wall of the observatory there. And you can see some instruments in the back here, including our weather measuring stuff, not to get too technical on you or anything. And then we have the all-sky camera here, which I've popped up there. And so the all-sky camera is what permits us to, check the weather, see what the conditions are roughly like. Is it really clear? Is it totally overcast? Is it kind of hazy? So that's what we use mainly the Piishi all-sky camera for. And the camera is still relatively new to us. It's not even a year old yet. This replaces our previous camera. And we use a ZWO ASI 183 MC, so color camera. It's not cooled, but it's a very good camera, relatively low noise, as all CMOS sensors have today. And we use a Fujinon 2.7 millimeter f1.8 fisheye lens that gives us a spectacular view of the sky above. So let me go ahead and show you the current view from the all-sky camera. I'm going to get it set up there. And we'll switch out our shares here. We'll just share that one. There we go. So here we go. Here's the current view from the all-sky camera. Mike Patton has to turn his light off there. So Mike, if you're listening, you might want to run back to the house and turn that off. We don't like lights out there. We want it very, very dark. So here's the current sky. We'll take just a quick look at the constellations. Notice pretty much all of our summer constellations are long gone. This might be Vega there, or no, not Vega, but Deneb. Yeah, that looks like Deneb there. I can see part of the Northern Cross in Cygnus. So we're pretty much losing those summer constellations, but we still have the autumn constellations riding fairly high. Many of them are centered around the Great Square of Pegasus here. So there's the Great Square. These three stars belong to Pegasus. This is the back of the flying horse. This is his head. So kind of a snout there. And then going from this star, there's like a front leg here and kind of a bent front leg here. And then this star belongs to Andromeda. This is Alpheratz, the head of Andromeda. And you can draw Andromeda as a stick figure, but it's easier to see two arcs of stars. There's Alpheratz, of course, and then three stars here. And then going back to Alpheratz, there's kind of three stars there. So that's Andromeda. And there's a little smudge right there. That's the Andromeda galaxy that we looked at back in November. But tonight, we're not going to look at the Andromeda, but we're going to look at a kind of relatively nearby galaxy to Andromeda and us, which is down here somewhere. That'll actually be our first target of the night. And taking a quick look at the winter constellations, we don't quite have the entire winter hexagon yet, or do we? No, we do. Last month we didn't, but this month we do. So we have the entire winter hexagon here, and we'll start with Rigel. Rigel's one corner of the winter hexagon. Sorry, people keep trying to get in. That's why I prefer everyone to show up on time, so I don't have to stop and let people in. But we have Rigel here, which is Orion's left leg, his left leg, which we see on our right. And of course, you can remember the shape of Orion by just saying three stars in a row, two above and two below. And of course, the two above are his shoulders, the two below are his legs. We have Betelgeuse, or Betelgeuse, as it's technically pronounced. And then we have Bellatrix and Rigel and Safe. So if you take some Betelgeuse, your belly will do some tricks, but if you take some Rigel, you'll be safe, which is spelled S-A-I-P-H. And then we have the three stars in a row, Alnitek, Alnilim, and Mintaka. And then there are some faint stars for Orion's little tiny head. You can see a faint arc of stars for his shield, and he holds the club up into the sky like so, kind of going up here toward Gemini. And then we have the sword of Orion below his famous belt. And of course, there's the Orion Nebula, which we're going to look at that next month because we look at that every season. But we are going to look at part of the Orion Nebula tonight, and that's just above the Orion Nebula proper. So we'll keep you hanging on what that might be. That's actually our last target of the night. And you can see the camera just reloaded. And thank you, Mike, for turning off your light. So now we'll go up to Aldebaran. This is the eye of the bull, Taurus the bull. And then we have the V-shaped Hyades cluster. Aldebaran is not part of the cluster, but it's kind of in the background, I believe, not the foreground, because the Hyades is like the nearest open cluster to us. So this is the face of the bull. There are various ways you can draw the bull. There's kind of like supposed to be like a leg here. I can't quite make it out in this view, but sometimes you show like this, like a straight line of stars, but sometimes there's like a leg here and kind of a leg here, like he's charging or bursting through the sky. Then on the back of the bull, we have the Pleiades. And yes, I will mention this little thing later. We go from Rigel to Aldebaran to Capella, and we're going to do a big stop here in Auriga later, right around this area here. So we have Capella with the goat stars. This little triangle of stars here is called the goat stars, because for some reason, Auriga, the charioteer, is making off with somebody's goats. So there's like a L shape for the chariot, and this is the head of the charioteer. So he's kind of making off with some goats in this general direction there. But otherwise, Auriga kind of looks like a big house in the sky. Very much like Cepheus, but a little more compacted or something like that. Then we have the twins, Castor and Pollux. Castor is the dimmer of the two, but it's a cool sextuplet system with 6 stars, 3 pairs. And then we have Procyon. It looks like they have a visitor, but we'll come back to the visitor later. So with Castor, you have a little stick figure here. He has like this little short neck and a long body and 2 little stick legs, kind of an arm here and an arm here. Then Pollux has this short little neck with 2 little hands or arms. And so they're kind of holding hands. He has a short body and kind of long bull legs like this. Then we go down to Procyon. So when I used to teach astronomy and had my students sketch constellations, this was always, I think, their favorite because it's just Procyon and this star here called Gomesa. And that's it, just 2 stars for Canis Minor, the little dog. Then we get down to Sirius, the brightest star in the night sky, and that's part of Canis Major, the great dog. So Sirius is kind of maybe the heart, or I kind of say the nose of the big dog. He has a triangular shape head. That's one way to draw it, with kind of a front paw here, a stick body, a back leg, and you can't quite see his tail yet. So his tail hasn't risen above these mountains here to the southeast. So you may have heard about the planetary alignment in the news, which of course is pretty much hogwash, but what we call it in astronomy is kind of a cool planet parade. And we definitely have that. Right now, for the past 2 days, yesterday and today, Venus and Saturn are like 2 degrees apart. They're at their absolute closest right now. So we have two planets right here, again, Venus and Saturn. Then moving along the ecliptic here, because they're always in a line, more or less, along the ecliptic, we have Jupiter, which is kind of lined up more with the top of the Hyades here. Before it looked like the Hyades was going to eat Jupiter, kind of like, like a Pac-Man game or something like that. And then right now, lined up with Castor and Pollux, we have the planet Mars, which was just at opposition on January 15th. So Mars is at its absolute best right now. So if you do have clear skies and good seeing, wait for Mars to maybe get a little bit higher and go out and check it out with a telescope. I hope to do that if it ever gets clear enough here in Michigan. It's kind of partly clear here tonight, but not really good enough to venture out. Plus, it's terribly, terribly cold. So let's go back to our little slideshow here. And as usual, the very first telescope we're going to use tonight is our Takahashi FSQ 106 EDX3. Real quick here, because for those of you that join us all the time, you hear this all the time. It's a 4-inch refracting telescope. Last year we removed, not last year, but I guess year and a half or so now, we removed the stock focuser and installed a Moonlight Nightcrawler 2, which is a very, very good focuser. A little on the pricey side, but it is a very good focuser nonetheless. And on the back of the telescope there, in fact, on the back of both telescopes, we have two of them, is our main camera, is our SBIG STX 16803 CCD camera. We are going to eventually sell these here fairly soon. We definitely won't get as much as what we originally paid for them roughly 10 years ago, because CMOS cameras have pretty much taken over. CCDs still have their uses, but they're kind of being left behind. CMOS chips, they're getting to where they're cleaner images, although CCDs would be the same if people would invest money in them. But CMOS chips are also cheaper to make than CCDs. So CCDs are being left behind as CMOS chips get better year after year. But this is still a very good camera by all respects. It's a full frame camera instead of the typical like 36 by 24 full frame cameras, which is what we might eventually get. This one's nearly 37 millimeters square, so it's a big old chip. Roughly 17 megapixels, which is kind of measly by today's standards, but still pretty good for an astronomy camera. And we've liked it a lot. It's taken thousands and thousands of pictures. I can't even tell you how many. So let me give you a live view of the remote telescope here. We'll just take a quick view of what the telescope actually looks like right now. And we can even give you a bit of a behind the scenes view. So this is the computer in the warm room of the observatory. So this is the computer that directly connects to the remote telescope. I access it via a web interface with this ordinary web browser. So the main thing taking up the view here is Maxim DL. This is what we use to control the camera and the auto guider. And then over here on the left is our weather station, so we can do a quick weather report. Looks like the wind has really calmed down, which is great. I did some private imaging last night, and I started probably 2.5 hours late because the wind didn't die down. If it's 10 or above, the observatory will automatically shut down. And it was kind of hovering around like 7, 8, 9, and then it would go above 10 for a while, then kind of go back down, then go back up again. Tonight, it was supposed to be roughly between 5 and 7 during the course of the session, but now it's down to 3, so that's a good sign. 5 5.7 miles per hour doesn't bug the Takahashi too much, but it kind of makes the other scope a little on the shakier side. So that's good. The wind speed's down there. And you can see the ambient temperature is nearly 50 degrees, 49.3 Fahrenheit to be exact. It's less humid than it was last night. Last night it was up in the 40s, which is high for out there, but now it's about 22%. So we'll check on the weather from time to time. This program down here is called M1 Oasis. This is what we use to roll the roof on and off the observatory. It gave me a little trouble tonight, but nothing too major. And then this is ACP. So ACP, or the Astronomer's Control Panel, this is what controls Maxim and connects to M1 Oasis and monitors the weather. So this is like the program that controls the programs and allows us to connect to the computer via, again, a web interface. But let me pop up the webcam there. Normally, I've been showing people a FOSS cam that Mike Patton owns, but he upgraded the internet access out there, and we currently don't have access to the FOSS cam via the internet. So we'll have to make do with our old PEC cam, which we used to stream to our website, but I think it's mostly a browser issue. We haven't been able to really get that to work. But here is the PEC cam that shows a live view of the remote telescope. So we'll talk about the big scope later, of course. This is our 20-inch plane wave, but this is the telescope we're going to start with here, a 4-inch Takahashi with the flip flap open. So we are 100% ready to go. So I'm going to go ahead and close this for the time being. We'll check in on it from time to time. And I'm going to hop back to the web browser, I think. Here it is. And then we're going to start my first target for the night, or our first target. I already have it entered in, so I'm going to hit acquire image, and we'll get going on this. Here we go. So yes, indeed, our very first target of the night is M33, the Triangulum galaxy. Now, we've imaged this galaxy several times during online viewing sessions, but we've always done it with the 20-inch. And I've always kind of avoided doing it with the Takahashi because I thought, oh, it might be a little on the small side. But boy, was I surprised when I saw kind of a test image I did a few weeks ago. So I figured, hey, let's do it with the Takahashi, and you'll probably be as amazed as I was when we saw this. So as usual, I show a little intro sketch here, or slide. This is a sketch taken by an amateur astronomer, just to give you a sense of what it might look like through a telescope, at least from a dark sky site. So it is visible to the unaided eye. The only time I can recall actually seeing this with my naked eye was between Flagstaff and the Grand Canyon. One of our members used to have a bed and breakfast out there, and when I visited him, he was just building it. Now he's since sold it and moved to like Alaska. And that was the only place I ever saw M33, the Triangulum galaxy, with my naked eye. So it's often said the Andromeda galaxy is the most distant object you can see with your unaided eye, but the Triangulum galaxy is a bit more distant. So for me, this is the most distant object I've ever seen with my naked eye, because it's about 2.73 million light years away. And it's often referred to as the Pinwheel Galaxy, but that name is generally given to M101. So it's in the constellation Triangulum, so why not call it the Triangulum Galaxy? This was probably discovered by the Italian astronomer Giovanni Battista Hodirna before 1654, and he noted a cloud-like feature near the triangle. And it was independently discovered by Charles Messier on the night of August 25th, 1764. And it was among the first spiral nebulae identified as such by Lord Rosse or William Parsons, using the massive Leviathan of Parsonstown, a big 70-inch Newtonian that's been restored today, and you can visit it and check it out. But that was way back in 1850 when he first saw this and was intrigued by its spiral shape. And that made astronomers wonder, were spiral nebulae in fact other Milky Ways? And it turned out the answer was yes, for the most part. So I already mentioned where M33 is located. So The Andromeda galaxy is up here, but you just go in the opposite direction from Andromeda to find M33. So this chart's pretty sufficient, but here's a more detailed chart that I borrowed from Sky and Telescope's Jumbo Pocket Sky Atlas, which I highly recommend. If you do not own a copy of Sky and Telescope's Jumbo Pocket Sky Atlas, I really strongly recommend it if you don't have any star charts to speak of. I know everyone has GoTo today, but it's a really great guide to have. So again, here it is, pretty easy to find along with the Andromeda galaxy there on the chart. So it's basically 4 degrees west-northwest of the 3.4 magnitude Alpha Trianguli, which is right about there at the tip of the triangle. And in fact, M33 and M31 lie on opposite sides and nearly equal angular distances from Beta Andromeda, or Meroc here. So you can go the same distance from here to Andromeda and from Meroc to the Triangulum galaxy. All right, let's see how we're doing on the program here. Now we'll go back to the web interface for ACP. So it looks like we are currently imaging. We're doing a 5-minute exposure, or 300 seconds, because it's always in seconds. And you can see our new guide configuration here, because our guiding has changed since last month. We previously guided through the 20-inch using an on-axis guider, but now we purchased a separate little guide scope from Stellarview, just like a little 50-millimeter guide scope, because using the on-axis guider has been kind of hit or miss. I haven't been terribly happy with it. So we're going to eventually remove that and image directly through the 20-inch. But now we do have a separate guide scope, and the guiding has been much smoother than it was previously. So if you've joined us in the past, you could probably see choppy guiding, but now it's pretty smooth. Although, again, it might be a little windy. It's 3 knots, whatever that is, probably around 3 miles per hour still. So the wind isn't too bad at all, but I did notice going to our friend David Churchill's website, he has an identical all-sky camera to ours. In fact, ours is based on his. His processing's a little better than ours, but still, ours looks pretty good. And what he has that we don't is a scene monitor. And now the scene's gotten a little bit better. It's 2.27. It was like 2.5 earlier, but now the scene's a little bit better. So the scene, it's pretty decent right now. But if you joined us back in November, it was pretty rough. That was a bad time for scene. All right, so let's check out okay, we're doing good here. So while we're waiting, I'm going to go into the participants and allow everyone to unmute themselves. So I've done that, so you can unmute yourself now. And we're almost done with the image here, but if you want to unmute yourself and ask a quick question, or as soon as the image is done, I would like everyone to unmute themselves anyway, so I can hear your reaction to the image when it appears on the screen here. And just remember, for those of you that do unmute yourself, we can hear everything you do in the background. So if you don't have anything to say, you might want to keep it muted. So we're almost done here. Just 5 minutes with the luminance filter, which is basically just a clear filter to keep dust off the chip. And for some reason, the web interface always goes a few seconds over, but the actual image does not. All right, now the image is done. What happens here is it downloads from the camera to the computer. Maxim's going to do a quick processing job. It's going to create a thumbnail image, and then it'll upload the main image. And as it does this, it does the plate solving in the background. It's going to count stars. So it found 28,164 stars in the background or the foreground, but it'll look for about 400 of those to do some plate solving. for the final image.
Hmm.
So we'll hear some bonks, and then we'll be able to actually view the big image here. Sometimes it takes a while. 400 stars is a lot of counting, and our computer's getting pretty old. We need to get a new computer too, along with some new cameras. There we go.
Jesus Christ.
All right, is everyone ready? Here is the first
Ready.
image of the night. Drum roll, please. Okay, here we go. There we go.
Wow. Very nice. Very nice.
Amazing.
It is.
Very
Thanks,
impressive.
Richard.
Great.
Nice.
Beautiful.
Very nice.
Mm-hmm.
Beautiful.
So this image is not at the full size, and later on, maybe late tonight or probably tomorrow or even into Monday, when you download these images, you'll be able to zoom in a bit more and see more detail. But that's pretty decent there. The stars do look a little on the puffy side, so it does look like the scene is still a little on the rough side, because before it was pretty sharp. So there we go, M33 of the Triangulum galaxy. Now we see it inclined at about 54 degrees, providing us with kind of a face-on view. So it's not perfectly face-on, but it's a bit tilted by 54 degrees. So that makes it look a little more ovalish than it might actually be. So this galaxy is about 60,000 light years in diameter compared to 100,000 for the Milky Way, and it contains about 40 billion stars. And the Milky Way has between 200 and 400 billion. So it's nowhere near as big or as massive or as populous as the Milky Way galaxy, and especially the Andromeda galaxy. So this is the third largest member of the local group of galaxies, a small galaxy cluster that we are a part of, along with Andromeda, the Milky Way, and of course the Triangulum galaxy. And again, it's roughly 60% the Milky Way size. It is currently moving toward M31, the Andromeda galaxy, and many suggest that it could be a satellite galaxy of M31. M31 and M33 are less than 300 kiloparsecs distant from each other and may eventually merge together in 2.5 billion years. At least that's what some sources say, but every time you see a galaxy simulation of the Andromeda and the Milky Way colliding, M33, at least the ones I've always seen, survives. So I think it's going to make it. I think it's going to become a satellite galaxy of the new galaxy when Andromeda and the Milky Way do merge. Now, oddly enough, you may have heard that many galaxies contain supermassive black holes at their center, but this one, as far as we can tell, does not. And it also contains NGC 604, one of the largest known emission nebulae, which is roughly 1,500 light years across. And it's easier to see when you do it in H alpha, but it might be over here. But you know, it's hard to tell in a grayscale image. So there are a few basic facts for you on the Triangulum galaxy. Any questions about the galaxy or the telescope that took the image or anything like that before we move on? All right, hearing none, we'll go ahead and move on there.
That's a bunch of stars.
It is. All right, so we're going to do another target here. I'm going to IC 405. Oop. My keyboard is getting really bad. I'm just going to hit the get coordinates, but just to make it go a bit quicker. But I'm going to punch in some custom coordinates here to frame it just the way that I want. Because, yes, I've done this before, but this is the first time we're doing this particular target during the online viewing session. So this is a new one. Not just new for the Takahashi, it's new, period. All right. Doesn't have to be so precise, but what the heck, I'm a perfectionist. And let's hope this does it. Okay, now this time we're going to go long. We're going to do 10 minutes with the hydrogen alpha filter. All right, off we go. All right, so we really have several targets, not just one, but I'm going to focus on one object here, and that's what I've entered in, IC 405, the Flaming Star Nebula, which is in the constellation Auriga, the Charioteer. So it's a lot brighter than I suspected because from all accounts, this is a pretty nice nebula visually, but honestly, if I've ever observed this one visually, I can't remember it. But it's about 6 magnitudes, so it's not terribly, dim, not especially bright, but not really, really dim. And it's pretty big, 37 by 10 arc minutes. So 30 arc minutes for comparison is half a degree, which is the diameter, the angular diameter of the moon. So that's why we're using the Takahashi, because it's a big target and it's roughly about 1,500 light years away. It's also cataloged as Sharpless 229 in the Sharpless catalog of emission nebulae, but it's also known as Caldwell 31 in the Sir Patrick Caldwell Moore catalog of objects that Charles Messier missed. And it was discovered by a gentleman named John Martin Skiburl, seen here. He discovered it in 1882. And as I did a little reading on him, because I'd never heard of him, he was actually a somewhat interesting character. And there's a bit of a local flavor here. So he was actually born in Germany as Johann Martin Skiburl. But, he changed his name to John, but apparently everyone called him Martin. But immigrated as an infant to the United States and settled in Ann Arbor, Michigan, just a short drive from Kalamazoo. He graduated from the University of Michigan in 1876 as a civil engineer, but devoted himself to astronomy. He actually taught astronomy at U of M from 1876 to 1888 and maintained his own private observatory. And from there, he discovered 3 comets, 2 of which that were in 1880 and 1881. I tried to see if there was an image of his observatory online, but I couldn't find anything, unfortunately, so I don't believe there were ever any pictures of it. Now, he's actually best known for discovering Procyon b, the faint companion star of Procyon, which is Procyon b is a white dwarf, in 1896 at Lick Observatory. He was one of the original staff astronomers at Lick Observatory when he left U of M to do work out there. So Procyon b was actually known to already exist by astrometric methods, but he was the first one to see it visually. So he kind of knew where to look for it. But he's still considered the discoverer of it, even though it was rediscovered on paper before anyone ever actually saw it. Kind of like with Neptune. And eventually he moved back to Michigan when he was kind of turned down for a directorship at Lick Observatory, and he died in Ann Arbor on September 17th, 1924. And you can see his headstone at a cemetery, I forget which one, in the Ann Arbor region. So kind of a nice little monument there to his work. Not a terribly famous astronomer, but still a bit of a local story there. So the name of our target, the Flaming Star Nebula, comes from the German astronomer and astrophotographer Max Wolf. It's, again, found in the constellation Auriga. They both start with an A, but it's found in Auriga, kind of toward the door of the house, as it were. And this time we definitely need to see a close-up chart, because with our large field of view with the Takahashi, we're going to get in several targets in here. So here's IC 405, our featured target, the Flaming Star Nebula, but we're also going to capture IC 417, which is pretty small. We'll get that. But we'll also get IC 410, which is pretty impressive. The cluster will be visible, but a little hard to see amongst all the nebula. Plus, we're using the hydrogen alpha filter. So we'll see NGC 1893, and we'll also get in M38 and NGC 1907. So you get several here for the price of one tonight. But basically, to find this on your own, it's not really that difficult. You just work from Iota Auriga here and go basically just 4 degrees to the east-northeast, and you'll come across it. And it is considered one of the true gems of the winter night sky, and apparently a popular target for amateur astronomers, but I can't ever remember observing this. I've observed M38, I don't know how many times, but I've never checked out the Flaming Star Nebula. So if we have clear skies at one of our winter viewing sessions, I'm going to make a point to check that out. All right, let's go check in how let's check in how ACP is doing here. Oh, so we're imaging away. Yeah, the scene looks pretty rough again, like it was in November. Usually it's a very smooth graph, but it's getting a little bumpy. So that's going to cause us some issues tonight, but that's not too bad. And we got a long way to go. So while we're waiting, before I do that, let's hop back to the all-sky camera. So again, we're collecting photons from this area right around here right now. One of these days, we're going to check into the all-sky camera here, and there's going to be like a big old bright meteor that zipped across the sky, but hasn't happened yet. It's going to happen one of these days, though. And again, if you're joining us for the first time, you might wonder what this thingy here is. This is a bird perch right next to the all-sky camera. So it's actually very small. It just looks big in the image here. And this has worked very well to keep birds off the all-sky camera dome and, you know, from leaving their droppings there, because we had to clean that thing constantly before we put the bird perch in. Now we barely ever have to touch it, which is awesome.
Richard?
Yeah.
John Shirley was buried in Bethlehem Cemetery, Ann Arbor.
Oh, thank you. That's right. Now that I hear it, I remember it. Yes, that's where I found the picture of the headstone.
That's it. So I'm looking at the same thing on Google.
Yep.
That's John Find a Grave site. That's where it is.
All right. And there's the current position of the remote telescope. Auriga's pretty high, as you saw on the all-sky camera, but not quite at the zenith. So there's the Takahashi imaging right now. And we'll kind of turn that off because we don't want the infrared camera to affect the image any. And you can see it is doing a 10-minute exposure with the, there it is, hydrogen alpha image. The guide star should be perfectly centered there, so it's a bit off. So again, the scene is again rough tonight, as was predicted. Because if you look at the, we'll actually go back and look at it. We'll scroll down here, and you can see the wind's down. Usually this red dash line is at 10, but I bumped the cutoff limit to 20 in case we have any issues with the wind. But right now, it's being really, really good. But we'll go down to the clear sky chart here, and here's the scene for tonight for basically the bulk of the session. And when it's light blue like this, that means poor. So when it's a bit darker blue, as it will be a little later tonight, for maybe the last hour of the session, this is where it's average. So maybe it'll get better as the night goes on. But yeah, it's another rough night for seeing like it was in November. But for those of you that joined us last month, boy, we could see just lots of sky glow and some cool structure. It was very dark last month. And we still got about a little less than 5 minutes to go. So again, we are here to talk astronomy. So if anybody has any other questions about astronomy, the telescope, the astronomy club in general, please ask. Help me fill some time.
What's the diameter of the large scope?
The big scope's 20 inches. We'll give a little more detail on that when we switch to it later. And we do currently have a full house here on Zoom. At least we did. Now we're at 99. So if somebody got bumped or left, and we have about 22 on Zoom. And I'll check the people are actually chatting in the chat, which is very nice. But I don't see any questions. So let me hop in. I can hop in the chat. Nope, nothing in the chat. Boy, you guys are a tough crowd. I mean, come on, we need some filler here, people. You're making me do all the work, and I only have like this much tea left, so I'm in big trouble. My voice isn't going to last that long.
So I took your class and enjoyed it very much, your Zoom class. I bought the Night Watch book, and it's been very helpful for me just learning about astronomy.
Oh, wonderful. I love Night Watch. And somebody just asked, are we able to download tonight's images? And the answer, of course, is yes. I will give you the link to download those at the end of the night, and I'll probably process them right after we get done here. But if I decide I'm too pooped, I'll probably do it tomorrow. And if they're not online by late Monday, then you can email me and harass me. But don't contact me until Monday evening at the latest. And so someone asked, what books would you recommend to learn more about astronomy? Well, if your main focus is amateur astronomy and, a little bit of the basic astronomy, I highly recommend the one just mentioned, Night Watch by Terence Dickinson. There's a second co-author, but his name escapes me now because, unfortunately, as many of you know, a couple of years ago, Terence Dickinson passed away. But the Backyard Astronomer's Guide by Dickinson and Alan Dyer is very good. It covers all the same stuff that Night Watch does, but a little bit more. It's a little more into the astrophotography portion of the hobby as well. It is a bit more expensive of a book, but still really, really good. And again, they both cover the basics of astronomy. But if you're looking for more of the astrophysics, there's a good one. I wish I had it with me. I don't have it nearby. I forget the exact title, but it was co-written by several authors, mainly Neil deGrasse Tyson, but also by J. Richard Gott, who was our guest speaker at our January meeting, and one other author, and that covers some of the really hard astrophysics topics. If anyone wants to throw the title into the chat, that would be great, but I can't remember it right now, and it's in the other room, and I'm not going to get up and go look for it. But we should go back and see how we're doing here. Oh, almost done. Oh, look how awful the scene is. Oh boy, that's terrible. Boy, is that bad, because that graph should be flat. And we are at the zenith too. Oh, that's bad. Well, if the image is really fuzzy, I might give you the test image that I took to download instead. I've been doing that a bit this season. The Flaming Star Nebula is both an emission and reflection nebula. In fact, that's the first thing I'll mention when I get back to my notes here. So it's both. And I bet the stars are going to be kind of blobby. Hopefully not too bad because we're in hydrogen alpha. All right. So again, it's going to download. Maxim's going to process it. Oh, there we go. We can see some nebulosity already. Let's see how many stars. This time we only have 14,872 stars. All right, so go ahead and unmute yourself when we unveil the big image here. It always looks brighter in the thumbnail, by the way, so let me dampen down your expectations. It's going to be a little dimmer in the big view. All right, here we go. Oh, the guiding's terrible. Oh, yuck. Well, it looks like we're chasing the bad scene tonight. So the image is pretty streaky. So I will definitely give you my test image as opposed to this view, which is pretty bad. So I've never canceled or postponed an online viewing session for scene before, but I might want to start thinking about it for the future. Because boy, that's trailed. We're chasing the scene, and that's why it looks like that. So yeah, but not too bad. So I will give you my test image, which is much, much better. But here it is. So we have a lot going on here. This is the object that we were after. This is IC 405, the Flaming Star Nebula, with this big kind of off appendage here. So again, this is both an emission and reflection nebula that surrounds the hot blue O-type main sequence star AE Aurigae, which I believe is the big bright streaky one there. Oh, what a shame. And so this is a pretty massive star. It has 23 times the mass of the sun, and it's 7.47 times the radius or diameter. So it's big. It has an effective temperature of 33,000 Kelvin on the surface compared to 5,800 Kelvin for the sun. And it's 59,000 times more luminous than the sun. AE Aurigae is also classified as an Orion-type variable star, and its brightness varies irregularly, which means it's an Orion-type variable, because that's what they do. They vary bright in a irregular fashion and have big outbursts. But it varies in brightness between 5.78 and 6.08, so not terribly dramatic, but still noticeable. It's a runaway star. It was not born in this nebula, as big stars like this often are. And it may have been ejected during a collision of two binary star groups in the Orion Nebula's trapezium region, or the trapezium cluster, about 2 million years ago. And this flaming star nebula is about 5 light years across. And up here, we have IC 410, the Tadpole Nebula. This is much more distant. This is 12,400 light years away. And it's associated with the open cluster NGC 1893, which is kind of lost again in the nebula here, but you might be able to pick it out when you zoom in on the replacement image I'll give you later. So this one's more than 100 light years across. And it's called the Tadpole because you can just see them here, but we can't really zoom in much more to see them. But when you download the replacement image, you'll be able to see the actual tadpoles here. They are really, really cool. So these tadpoles are gas globules that are small, dense knots of dust and gas that give birth to young stars. And this nebula was discovered photographically by the German astronomer Max Wolf, who we mentioned earlier, on September 25th, 1892. And then we have, gosh, what was it from the chart? IC 417. And then scrolling down, again, it's really hard to see here, but this is M38. And this is the NGC cluster that I forget the designation of, NGC 1900 something. But here's M38. And again, that's it's not the best image we've ever taken, but again, it's a night of bad scene. And when the star's bouncing around because the atmosphere is unsteady, the guider chases that. And so we get a trailed image like this. So that's what causes that. So bummer. It can't control the weather, you know. So, oh, by the way, M38, that's an open cluster in Auriga. I guess that's all we'll say about that. I was going to mention more, but I'm too let down to mention more. Darn. Okay. Let's go to our final target with the Takahashi. We'll do NGC 2264. Oops, 64. Make sure I hit get coordinates. I have forgotten to do that before. And we'll hit acquire image. And off it goes. We'll leave it like that. All right, so NGC 2264 is mainly known as the Christmas tree cluster. It might have been more appropriate to do this last month, since we were 4 days before Christmas when we had our last online viewing session, but it was a bit too low last month, so I saved it for this month. It's also known, this region is also known as the Cone Nebula, but I'm getting ahead of myself here. So the magnitude 3.9 is not for the nebula, it is for the cluster, the Christmas tree cluster. So this is one of the brightest open clusters in the sky, but it's often overlooked because of the nearby Rosette Nebula, which is much more famous, and we'll probably do that next month. And again, it's pretty big, about 20 arc minutes. So that's a much more fitting target for the Takahashi as opposed to the 20-inch. Although one of these days we'll do the Cone Nebula itself with the 20-inch, but we're not going to do that this time. And you can see it's about 2,350 light years away. So yeah, NGC 2264 is the designation for both the Christmas tree cluster and the Cone Nebula. It basically has a dual identity, which is kind of unusual for many objects. And two other objects not officially included are the Snowflake Cluster and the Fox Fir Nebula, which is a really popular imaging target. So it'll be in there. So the Christmas tree cluster is also cataloged as Calendar 112 in the Swedish astronomer Per Calendar's 1931 catalog of open clusters. William Herschel discovered the cluster on January 18th, today, in 1784, 241 years ago today. But he discovered the nebula on December 26, 1785, over a year later. Nearly 2 years later, really. And so the American amateur astronomer and poet Leland Stanford Copeland named NGC 2264 the Christmas tree cluster. He was a often contributor to Sky and Telescope, so he probably first mentioned the name in there. So it's in a pretty easy region to find, although Monoceros itself is a very difficult constellation to find because it's not especially bright, but we do have Gemini and Orion nearby to help us. So that's its rough position, but again, we'll get a close-up view with the Sky and Telescope Jumbo Pocket Sky Atlas. And so I mentioned the Rosette Nebula, which is there. That's a very popular target. But basically, to locate this, you can use the feet of Pollux, which is kind of broken into two parts here. Sometimes there's a line going here to here instead of whatever part is supposed to be, his leg. He has, like, a leg here and a leg here, so really two legs, but some charts show a straight line going from here to here. So locate Gamma Geminorum, or Gamma Gem, or Alhina, and Zeta Geminorum, or Zeta Gem. And you basically go from Xi here and just go 3 degrees to the south-southwest and you'll find it. Or if you already know where the Rosette Nebula is, just go a little bit north, because again, this area is overlooked for visual astronomy in favor of the more popular Rosette Nebula. And so both the Christmas tree cluster and the Rosette Nebula actually fit in the same field of view in 7x50 binoculars. So if you get this nebula in the northern field of view, or more aptly, put the Rosette Nebula in the south part of the field of view of your binoculars, you'll no doubt see the Christmas tree cluster up here. But don't expect to see the Cone Nebula, even if you got a bit bigger telescope, because that is difficult to do. All right, let's go back and see how we're doing. We'll see how crummy the scene is again. Oh, now it's gotten a little better. So maybe we'll have good luck this time, but boy, it was hopping all over the place last time. Very curious. Oops. I hit the bad button on my mouse. We'll just hit it back again. I hate that button. So now I got to fix my screen. Here we go. It only takes a second. All right, so we're guiding along there. So we got a ways to go. Let's go back and check on the all sky camera. And you can see again, Mike Patton has his light off. Thank you very much, Mike. This is Mike's new neighbor. I don't know his name. He appears to have some lights on, but not too offensive. When he first moved in, he had this really bright light in the window here, it seemed, and you can go back and view that, I believe, November 2023 session, where I complained the whole time about it. But he's been much better since then. This house in the distance with the lights on, that's Rick Benno's house, who owns a large house and observatory out there, plus a 24-inch plane wave. And you can't really see any sky glow, but sometimes there's a little glow over here. And I'm not quite sure where that's from. The nearest town roughly in this direction is Animas, New Mexico, but that's far enough away to where it shouldn't cause any problems. But everything looks pretty good there on the all sky camera. Oops. Oh, and somebody asked what usually causes the streaking. I did mention it's from the bad scene. Sometimes the wind can knock the scope around, but as far as we can tell, the wind has been very calm right now. So my guess is it's mostly the scene conditions got really bad there for a minute. But let's go back and look at the computer. So now the guide star is nice and centered, because you might recall before it was kind of toward the top of the little image here, or the little window. So now it tells me the scene is much better. It's now stabilized a little bit. The wind has bumped up a bit. It was supposed to be between 5 and 7 miles per hour, so at least we're in the forecasted range now. But this won't cause any major issues with the Takahashi, and not really any serious issues with the 20-inch if it stays around here. But we just don't want it to get toward 10. That's when things get a little on the shaky side. All right, we'll go ahead and stop sharing there. And again, we welcome questions and comments. And like, for example, how many folks found out about the session from Sky and Telescope and are joining us tonight? You saw it in the Sky and Telescope news bulletin.
I did.
Oh, great. Yeah, they've been very kind to us. I'm not sure, it's not like we're greasing Sky and Telescope's palms, but they featured many of our events in the news bulletin, and we're very grateful for that. But we haven't done anything to do that. We didn't, again, pay anybody or suck up to anybody. They just do it out of the kindness of their heart.
Hi, Richard. This is Kevin Lamar from Maine. That's how I found out about your astronomy class last year, was through your weekly messenger. And I wouldn't have known about it. And that's how I found out about the KAS. So, yeah, they're great. They put out a lot of good stuff on behalf of, you guys and others.
Wonderful. Thank you. And I sure was glad the skies were clear in Maine for the eclipse last year, because that's where I went.
Yeah, I live in southern Maine. I was going to go up to Millinocket, but then I had second thoughts about the traffic congestion. And after watching evening news, I was glad I stayed right where I was. I didn't see the full totality.
Oh,
we got some great photographs. I broke out my 1966 Edmund 4 1/4 inch telescope and snapped a bunch of great pictures with that. So yeah, it was good. That was a great day all over the state.
it was. The drive, I stayed in Waterville, Maine, and the drive up that morning to Jackman was really good, but That 2 hour drive turned into a 5 hour drive on the way home, but nothing really bad. So it was definitely worth going to the Path of Totality because it was spectacular.
I'm originally from Waterville, so it's a halfway point.
Great. We're going to go ahead and mute you there because you got some background noise there. At least somebody does. No, maybe it's not you. Oh, there you go. I think.
It could be me. My computer's working hard tonight and it's groaning.
Oh, uh-oh. All right. Anybody else? Comments? Criticisms? No criticisms. I'm delicate. Don't pick on me. looks all clear there in YouTube land, or yep, YouTube land. Yep, and basically what we're doing here for the online viewing session is a form of EAA, or electronically assisted astronomy. That's and we've been doing this before EAA got really popular. We started doing these sessions in 2019. We tried doing them in person first at on the campus of Western Michigan University, but then we just discovered, it's much more fun and easier to do these online. So since 2020, we've been doing these as online viewing sessions, and the fact that we started doing these online during the pandemic was just a coincidence. It just kind of worked out for everybody. And we've had great success with Zoom, especially during the pandemic, but even after. Are you still offering your lessons for sale? Technically, yeah, I don't make a big deal out of advertising it yet, but if you do want to take a full-blown astronomy course, 21 lectures, I believe it's 21 or 22, I think it's 21. It's my Introduction to Astronomy course, the same course that I taught at Kalamazoo Valley Community College, Western Michigan University, Glen Oaks Community College. You can give me $100 and I will send you the secret links to those classes. One of these days I might offer it live again, but I'm not planning on doing it anytime this year anyway. Because if we ever do it live, not only do we do the lectures, there's, of course, homework questions to answer, there's tests to take, but there's no grades. But the lectures themselves are available secretly on YouTube. I don't plan on making those publicly available. And I just heard ACP, our image is finished, and there's the thumbnail. Again, it's not going to look that bright, so let me dampen down your expectations there. It looks so much brighter in the thumbnail. And again, this is the first time we've done this target, so 3 new targets for the Takahashi, 2 of which are totally brand new. We've never done them before. All right. Here we go. So go ahead and unmute yourself. Hopefully the image will be a lot better than the last one. Boy, I'm still bummed by that. Here we go. Oh, much better.
Very nice.
Oh, yes.
Nice.
Very good. Happy Christmas.
Yes, indeed. Okay, so you can see the stars, but again, they're a bit dampened in hydrogen alpha, but the nebula kind of makes the Christmas tree shape too. So that's where the Christmas tree cluster is. These are all the stars in the Christmas tree cluster. So the Christmas tree cluster is an extremely bright and extremely obvious open cluster. Quote Stephen James O'Meara there. It's visible with the unaided eye and well resolved in binoculars. So after the session, if you have clear skies and the moon's not up yet, go check it out with binoculars. In binoculars, It consists of about 80 stars from 8th magnitude and spans about half a degree. The field of view here is roughly 4 by 4 degrees, by the way. And the cluster has a physical diameter of about 30 light years. So that could be roughly from this way or this way. Since it's kind of tree-shaped, it's hard to tell from which way they're talking about there. But a lot of this gas and dust blocks our view of other stars in the cluster. So in all, the cluster contains more than 600 members that are only 1 to 4 million years old. And yeah, only, for stars, 1 to 4 million years old is nothing, given that the sun is, 5 billion years old. So the cluster is embedded in an extensive but tenuous nebulosity visible in larger telescopes under clear, dark skies. But I've never observed this nebula either personally. So here's the Cone Nebula right there, which is my favorite object in that field of view. So the Cone Nebula lies at the south end of the cluster and is difficult to detect visually. Both are members of the Monoceros OB1 Association, which is like a group of stars that are not really gravitationally bound, but they have a common origin, so they move in the same direction. And it's all located in the Orion arm of the Milky Way. So the cone here is what's called a dark nebula, consisting of cold molecular hydrogen and obscuring dust. The faint nebula is about 7 light years long. So from maybe roughly the top here, which is what we can call the top, toward the bottom here, which is kind of tapers off, that's about 7 light years right there. Or in angular diameter, about 10 arc minutes. So one of these days, we'll take a close-up look at the Cone Nebula with the 20-inch. But we'll save that for maybe next season. Who knows? Maybe next month. I don't know. So there we go. And lots of other nebulosity, even some dark nebulosity here again in the field of view. So really, really interesting region. Not one of the most visually spectacular, like say the Orion Nebula or the Rosette Nebula, but it's pretty interesting nonetheless. I hope you enjoyed that one.
So Richard?
Yeah.
Richard? Yeah, this is Becky. So which stars are part of the OB1 association as we look at this image?
Probably mostly the bright scattered ones. Okay.
And are those also part of the Christmas tree cluster, or just some of them are?
They might be the bright ones for sure are probably associated with the nebulosity, but they might not necessarily be part of the cluster.
Okay.
Because I think the cluster is mostly in a half a degree area here.
Okay.
So
Thank you.
like say this bright one down there, that might be part of the association, but I think that's too far from the heart of the cluster to be part of the cluster.
Okay, thanks.
Yep, you're welcome. Any other questions before we move on here? All righty. So let me scroll down here while I'm on the ACP web interface, and I'm going to hit, well, actually, before I do, I'm going to make some changes in ACP here before I forget, because if you've attended sessions in the past, you know I forget easy, but I got to change the settings in ACP here for the big scope. Okay, that's done. And now I'll go back to the browser and we're going to switch to the big camera or the big telescope. Same size camera. All right, so that'll work in the background there. I think I hit it.
Really beautiful nebulas.
Thank you. Okay, so now we're going to check out some stuff through the big scope here. So yes, this is our PlaneWave CDK20 telescope, which is a 20-inch corrected dull Kirkham telescope. not like it's kind of a compound telescope like a Schmidt-Cassegrain, but this has a ellipsoidal primary mirror and a spherical secondary mirror, plus a little lens group in the back, which gives you the corrected Dole-Kirkham telescope. So it does have a 20-inch mirror, and it weighs in total about 140 pounds. So you can see it in comparison with the Takahashi here. And here's our main imaging train on the back. Of course, the only thing to change here is we have now moved the autoguider to a separate guide scope. And we'll get a picture of that for future use later. But we use the same exact camera, same exact filter wheel and filters on the 20-inch as we do the Takahashi. To focus, we use a finger length instrument Atlas digital focuser, this kind of black box on the back. And we're still currently using an Innovation Foresight on-axis guider. But we're going to remove this and connect the camera and filter wheel directly to the telescope. Right now, we're trying to figure out exactly what spacers we might need to use. And so both telescopes right atop a software bisque Paramount ME2, which is a pretty high capacity mount. It holds 240 pounds of instrument capacity, 480 pounds total capacity, including the counterweights. We probably have several on there. We probably don't need all these, but they think we do. But one of these days I'll get out there and see if we actually do need all these counterweights, because we sure didn't when I was out there. I balanced it just fine, thank you very much. But it is a very, very good mount, but it can adjust for bad seeing, as we found out earlier. Okay, so let's switch back to ACP here. I believe we're all switched up. We are ready to go. And we're going to do one that has always been a personal favorite of mine. We apparently have done this before, but I can't find any record of it. So we may have done it during the first season that we did in person at Western, and also partially on Zoom. Oh, no, we didn't do them on Zoom at all back then. But we've never done this during an online viewing session. So we're going to do NGC 7789. We're going to bump this down to 5 minutes because it's pretty bright. And we're going to use the luminance filter. So I believe we're ready to go. And I did change the aperture and focal length, so we're good to go there. All right, so NGC 7789 is Carolyn's Rose Cluster. And it's a pretty spectacular cluster visually. Whenever we have this object high in the sky during a public observing session at the Kalamazoo Nature Center, this is one I always go to because I really enjoy viewing this one so much. It's a very, very rich cluster. It's not really faint. It's pretty big, 7,600 light years away, but it's amazing to me that this beautiful cluster is neither a Messier or even a Caldwell object. Even Patrick Moore forgot to include this in the Caldwell catalog, which is a major oversight, in my opinion. So it is one of the brightest and largest open star clusters in Cassiopeia, along with the Owl cluster, NGC 457 that we looked at last season, M52, M103, NGC 654, and NGC 129. Cassiopeia is a rich constellation. It is slightly larger but fainter than the Owl cluster, while both are brighter and larger than the Messier clusters M52 and M103, which again is shocking that it's not included in either catalog. It's also known as Carolyn's Haystack cluster or the White Rose cluster because of groups of stars and it resemble the pattern of a rose petal. But I've always heard and preferred Carolyn's Rose cluster. It was discovered by Carolyn Herschel on November 1st, 1783. Carolyn's brother William Herschel cataloged the cluster as HVI or 6.30 on October 18, 1786. He described it as a beautiful cluster of very compressed stars. So before we move on, let me tell you a little bit about Carolyn Herschel here. She was born in Hanover, Germany on March 16th, 1750, and she died on January 9th, 1848 at the age of 97. So she almost lived forever. She almost pulled it off. 97 is pretty good for her time period. She's the 8th child and 4th daughter of Isaac and Anna Herschel, but she was struck with typhus at the age of 10, which stunted her growth, and she never grew taller than 4'3". And kind of for that reason, her poor health and small size meant her family thought she could never marry. So she was actually kind of a servant in her own house. So it was a very difficult, terrible life for her. So she eventually immigrated to England to be with her brother William in August of 1772. And eventually, she started her career as basically taking notes for her brother William as he made his observations. But then she went on to use her own telescope and make her own observations and made many discoveries, including the cluster we're imaging right now. But what she's probably most famous for is she discovered 8 comets between 1786 and 1797. And this was back at a time when discovering comets was a big deal for countries. So because it gave her and her country, her new country, a lot of fame, in 1787, she was granted an annual salary of 50 pounds by King George III. She was the first paid female professional astronomer. So a little bit about Carolyn Herschel there. So this cluster is pretty easy to find. Just look for the familiar W shape, or kind of M shape now, I guess, in this configuration of Cassiopeia, and look toward the more steep end here, as I call it, not the big wide part of the W, but the opposite end here, in that direction, which I can't think of off the top of my head. So here's a more detailed view with the pocket sky atlas. So it's basically located 3 degrees southwest of Beta Cassiopeiae, or the westernmost star of Cassiopeia's, very famous W pattern here. I cut off one of the stars there, but that's okay. This is the close-up. Was there a question while I was talking about Carolyn Herschel? I believe there was. Okay, so we're off imaging. We found another guide star. The guiding looks pretty smooth. So I'm not sure what caused that issue with the second image. It did look like bad scene to me. But maybe we found a rough spot for the mount. Who knows? But thank goodness we have a replacement image for that one. All right, so we're about halfway down there. Let's go back and check the all-sky camera. We're getting lower with Venus and Saturn there, but they're still there. So we still have our planet parade, Venus and Saturn, Jupiter and Mars over here. The neighbor has its lights off now, thank goodness. Rick Benno still has his lights on, but that's not a problem.
Richard?
Yeah.
Yeah, I checked my notes and you're right. We did view this object at our first remote viewing session in November of whatever that was.
Okay.
November of 2019.
Oh, that was the very first one.
But my notes say the image wasn't printed. And so I don't know why that was, whether that was just I didn't print it or for some reason it didn't work out. But anyway, yes, we had viewed it, but we don't have an image on it. At least I don't.
Yeah. Well, now we will fix that.
Very good.
What you showed that looked just like a face with closed eyes.
The cluster looks like a face with closed eyes?
Yes.
Okay. With clusters, you can make anything you want out of them. That's what's so amazing about them. We'll just go ahead and keep it on the ACP screen here. We're getting there. Much smoother guiding. All right. We're getting there. We'll scroll down here and see how many stars we get. That's always fun to check. I always wonder how accurate that is. It could be counting hot pixels too, or noise. $17,505 image stars found. That's a lot. Oh, and there it is. Oh boy. You can kind of see a face in the thumbnail there, don't you think? Kind of looks like a smiley face with kind of two wide eyes and a nose. So there you go. There's the face. Now we got to wait for the plate solving to finish, and we'll check out the big image. Yep, that computer's getting old. Hurry up. 247 stars matched. All right, now it's done. Here we go. Everyone unmute yourself. Carolyn's Rose Cluster. Ta-da!
Very nice.
Really beautiful.
Beautiful.
Caroline's Rose Cluster, nice.
Stars do look a little puffy, so I still think the scene is a little bit. But we'll fix that in processing later.
And that looks also like a nose and a mouth.
Yeah. You can kind of see a mouth here with a nose and eyes. There's even kind of funky ears. So at magnitude 6.7, it is at the limit of naked eye visibility from dark sites. I can't claim to have ever seen it with the unaided eye. When seen through binoculars, this cluster looks like a tailless comet crossing the rich star fields of the northern Milky Way. Small telescopes will reveal 40 to 50 members, while 8 to 10-inch telescopes will show up to 100 to 150 stars within a diameter of 20 arc minutes. It does contain 580 stars, ranging from 10th to 18th magnitude. A 2021 study identified 2,799 cluster members within a radius of 28 arc minutes. It has a physical size of 44 light years and a mass of 6,620 solar masses, so over 6,600 times the mass of the sun. At about 1.7 billion years, it is one of the oldest open clusters known, because typically open clusters only last for several 100 million years, because as they orbit the Milky Way, some of the really massive stars just might simply die, while the cluster will encounter, alien stars, those outside the cluster, or clouds of dust and gas that it has to plow through, which is the case of the Pleiades. So gradually they lose their members one by one. So for a cluster like this to survive 1.7 billion years and still be so rich, this must have been at one point a super star cluster, just a massive, massive cluster. So 1.7 billion years is pretty old for many of the more massive stars to have evolved. And so the brightest stars are all orange giants of type K43, which are Roman numeral 3, which is the classification for giant stars. And they all have an absolute magnitude of about minus 2.3. For comparison, the absolute magnitude of the sun is 5, positive 5. So these giants are much more luminous than the sun. So if you ever do observe this cluster again visually, maybe defocus it a bit, because that tends to bring out star colors a bit better, and you might see some of those orange giants in the cluster. But of course, with a quick monochrome image, this is the best that we can do here. So there we have it, Carolyn's Rose Cluster. And we'll process this a bit, so we'll make the stars a little more sharper, so it looks a bit better in the version that you'll download later. All righty. So for our next target, we're going to go back to the nebulae, and we're going to go to Orion now. We're going to spend the rest of our night in Orion the Hunter. And the first one we'll do is a very popular target called M78. Why don't we go crazy and do a 10-minute shot with the hydrogen alpha filter. I did hit get coordinates right. Let me do it again. Yeah, I did. You got to be careful there. I can't walk and chew gum at the same time. It's a character flaw. All right. So M78 doesn't really have a proper name per se, but I always call it the other Orion Nebula, because of course M42 is the one that gets all the glory, but this is another fairly significant nebula in the constellation Orion, so why not call it the other Orion Nebula? It's not nearly as bright, at magnitude 8.3, it's beyond the limit of naked eye visibility, and it's still a pretty decent size though, 8x6 arc minutes, and it's at the exact same distance as the more famous Orion Nebula, because it's all part of the same molecular complex in Orion. So we all know the Orion Nebula is in the sword of Orion, but M78 is kind of up here in the belt, just above the belt really, in kind of a more obscure region of the Orion constellation. But we'll zoom in for a bit of a more detailed chart there. So it's located about 2.5 degrees northeast of Zeta Orionis, which is Alnitak. Down here we have the Horsehead Nebula, but we go in the other direction there. And that's where you'll find M78. And this region also includes companion nebulae, NGC 2064, 2067, and 2071. All are reflection nebulae that shine by the reflected light from hot young B-type stars. So this is one of the big three nebula in Orion that of course includes the Orion Nebula, which is M42, M43, and also NGC 2068. It was discovered by Pierre Méchain, Messier's assistant, on October 29th, 1780, and included by Charles Messier in his catalog that same year. It is the only principal reflection nebula in the Messier catalog. Now, the Pleiades has reflection nebulae, but only the cluster is technically part of the catalog, not the nebulae in the Pleiades. So its nature as a reflection nebula was discovered by Vestal Slifer of Lowell Observatory in 1919. If you're familiar with Vestal Slifer, he did similar work to Edwin Hubble. In fact, he discovered the accelerating universe or the expanding universe a bit quicker than Hubble actually did. But of course, Hubble gets most of the credit, at least in popular writings. All right, let's see how we're doing in ACP there. Oh, we got a big slew, so it looks like the telescope is it's just now getting to its target. It just finished slewing. So now it's going to look for and it already found the guide star, and now we're just starting our imaging process there. Let's check on the all-sky camera. Oh, we still got Venus and Saturn. That's what I wanted to check on there. let's see how the scene is now. Let me scroll down the David's page here again. And it's 2.16 now, so it's gotten better. So we do know it got pretty rough there for a while based on that one image, but what are you gonna do? All right, let me check the chat there. I haven't checked out the chat there for a while. Don't see any direct questions in the chat there. So let's go ahead and stop sharing there for a minute and see if we can get anyone to give Richard a break. Again, we welcome questions and comments and all that sort of thing. How many folks have clear skies where they are now?
I had for a while clear skies, but now it's again completely cloudy.
Oh, that's probably what it is here too. Because I did run out to check
not
our,
even
yeah.
not even close. Not even close for clear skies. Oh well.
Well, it is January.
Yep.
Richard, like Desert Coin, like you here in Kalamazoo, yeah, clouds ready to snow.
Yep, typical January in Michigan. I was hoping to get out to the nature center and observe the occultation of Mars, but it was cloudy. But then the next day, at least in the early evening, when the occultation happened, it was actually clear. So did anyone see the occultation of Mars?
Yes, last night.
Oh, you just shut up. I don't want to hear it.
It was very nice here last night. We had a really, well, the sky wasn't as clear as it is right now, but it was pretty nice. Cold.
So, yeah. I've never seen an occultation of Mars. So it was cloudy on Monday when it happened, then clear at least for a while on Tuesday, then it's been rotten ever since.
Yeah, it was pretty cool.
When it was finally clear, I was able to see and photograph Mars and Jupiter, and the first moon, and then Mars, and then Jupiter, and with a 6 times zoom, the planets on the UY P30 light, and with a telescope, 8-inch Dobsonian.
Oh, very nice.
And I placed it in space weather.
Well, thanks for sharing.
Welcome.
Let's zip back to Zoom there, or to the web browser. We're already on Zoom. See. Oh no! Look at that! Look at the saw teeth. It looks like the scene's gotten crazy again. Let's see where we are. We're nowhere near the meridian. Oh boy. Let's go look at the guide star. This might be another choppy one. Oh, and I gotta fix the screen here because we switched telescopes. Eh. There we go. We'll get rid of Focus Max there. We don't need that. I always focus once right before the session starts. Yeah, it looks pretty centered, but it looks really choppy. Oh, the wind's up too. That's probably the main cause now. Okay, yeah. So that's probably why things have gotten a little on the choppy side. It's gotten a little windy. Okay, so one of our friends from Ann Arbor is in Florida, and it says it topped out to 76 degrees Fahrenheit. Jeff, you can keep that kind of stuff to yourself. I don't want to hear it. It makes me feel bad. Yeah, this might be caused by the wind this time than the scene, but what are you gonna do? Can't control the weather. But boy, if you joined us last month, we sure did have great conditions last month. Boy, was that dark. Lots of sky glow. Pretty good scene, too. In November, we had pretty rotten scene. It was even worse than it is tonight. Well, this is probably going to look pretty traily too, but we'll go ahead and let it finish. Oh, dang! I hit that stupid button again. I hate this mouse. I gotta get one without the button. So we'll fix that. Well, I was going to do some imaging after the session, but with the bad scene, I don't think I'm going to. It's pretty rotten. Oh, they're getting closer. Pretty soon Venus and Saturn are gonna set. So yep, remember we're imaging right about here. You can't see it in the image, but you have Barnard's loop here. That's even too big for the Takahashi. There's the famous Witch Head Nebula over here. We've done that with the Takahashi before. And Mars looks pretty orange. Oh, you can see the rest of the dog's tail now. Remember, that was below the mountains when we first started. So those constellations are getting higher. And we've lost, no, it's still there, but we still have the Great Square. I think we still have Deneb. That's probably Deneb there. We got one prominent star of summer. Oh, and you can see the bowl of the Big Dipper. So we got M81, M82 here. We don't usually get to do those. If we did a online viewing session in March, we could, but I tend not to do the online sessions when daylight saving time is in effect. Oh, I'm hearing an alert, which means we may have lost our guide star. No, it's still there. I don't know what that little alert was. Oh, star faded. So yeah, the seeing conditions are causing issues, it looks like. Or again, it could be the wind, but it's kind of calmed down a bit. Well, it's going to be a struggle to get this image done between the wind and maybe the bad scene. The scene's been pretty rough out there lately. It kind of comes and goes. It's stabilized a bit now, but oh my goodness. That's awful.
Looks a bit like a heart rate monitor.
Yeah, it does. So someone's having a coronary. Let's see. Can I join the KS as an out-of-state member? Let's see. Out of the nearly 400 memberships we had at the end of last year, about 70 of those were from out of state. So the answer is definitely yes. You do not have to be a local to join the Kalamazoo Astronomical Society. We do try to put most of our general meetings on Zoom. And of course, our online viewing sessions are always on Zoom. So you can at least participate that way if you're an out-of-state member. But of course, you do miss like, you know, the picnics and the parties and field trips and public observing sessions. But you get the newsletter, you know, you still get the newsletter. So it's kind of half and half. We do have a supporting membership that's only $10. So if you do live out of state, you can join as a supporting member. What that basically means is you're technically a member, but you can't vote in any elections, you know, like who cares? And you're not a member of the Astronomical League. So we don't have to pay for you. But usually those that join out of state are already part of another astronomy club, and they get the reflector from their club, which is usually a AL member, but not always. All right, we're done. Now I'm guessing this is going to be a little on the trailed side, since things got a little rocky there for a while. Well, that looks terrible. Oh, maybe I shouldn't have done H alpha. Maybe I should have done a luminance image. Oh, darn. Well, maybe we'll come back to that one. Oh, yuck, that looks terrible. Blah. We're not even going to look at that one. Holy cow. I think the wind really knocked the heck out of that one. Let's give it one more shot.
Okay, good, good.
Yeah, I'm going to do a 5-minute shot with the luminance filter and see if we can get a more usable image out of that one. But boy, I'm not even going to bother to keep that one on the screen. That has got to be, without a doubt, the worst image we've ever done during an online viewing session. But, you know.
Oh, that one was pretty good to be bad.
Yeah, it was pretty good for a bad one. That was a good bad one.
Yeah.
Ah, no, go away.
Okay, we see it now.
Yeah.
You're a perfectionist.
Well, the good news is we don't have to slew very far, but we'll do a 5-minute shot with a luminance filter. I should have done the luminance filter to begin with. I don't know why I did H alpha, because it's a reflection nebula. Duh. So that was a brain fart on my case there, but it still should look pretty good. But boy, that looked pretty bad. Okay, so now what it looks delayed here, but it's probably fine. It's doing a 20-second plate solving image. It takes an image of the region of the sky we're looking for, matches it with plate solving, and then puts it right in the center. So plate solving is one of those miraculous wonders. Yep, that is a good example of a poor image. Hey, they all can't be winners. What do you want? Let's might be too late to see the, well, I don't know if that's the old guide star or the new one. Let's see what the scope's doing. So there it is.
And concerning Mars having been closed to 2003, and on Boxing Day 2003, we had a visitor, and when we brought her back, on the way back, I thought that a bright planet near the moon were Mars, and then after we dropped her off, we drove back to our house, and then there was a road construction, and then my mother asked me whether there's a traffic light. I said yes, and then I remembered that the bright planet is not Mars but Venus, so I said, no, this is Venus. And then my mother said, is there a traffic light? Yes. No, this is Venus.
Yeah, Venus has been mistaken for a plane and UFO many, many times. Okay, so quick update here. It looks like either probably the wind or most likely the scene is so bad it gave up on trying to get the guide star to go. And now it's doing it unguided. So we're not having too much luck with M78 tonight.
Would unguided maybe be better than our previous example?
Yeah, it won't chase the scene again, so or lose the guide star and try to find it. But it'll be a little trailed still. But I'll again look for an image, a better image from the past, and I will include that one with the download. So in fact, I think I'm just going to go ahead and kill this, and maybe we'll come back to it. I'll just let it go. What the heck? We're doing pretty good on time. Oh, new image from the all-sky camera. Oh, and there we go. It's gone. No more Venus and Saturn. Let's get a scene update. We'll hit reload there. That still looks like it's better, but it sure doesn't seem like it. Seems worse.
How was the wind?
Let's check. It is 6.5 miles per hour. So it might gust up a bit. That doesn't register. So we might be getting knocked around by the wind too. But the fact that we couldn't get that guide star to go means the scene is crummy. Because it looked pretty steady when it was trying to lock onto it. But overall, the new guiding routine has worked really well, but maybe we still have a few kinks to work out too. I might want to calibrate it a couple more times. But I'm not going to do it tonight. Because I know bad scene is part of our issue, but...
Is there any way to do like a test, one with the on axis and then one thereafter with the new guiding apparatus?
Well, the on-axis guider won't. I'm not quite sure I get your question, but
I was thinking about if you wanted to make a comparison in conditions to see which might be better.
When I know the scene is good because we've used the new guiding several times already. It's been excellent. Way better than it ever was with the other setup through the on-axis guider.
So it might just be the blustery wind.
Yeah, I think it's probably the wind, a combination of the wind and the scene. But you know, again, it wouldn't hurt to do a few more calibrations of the auto guider anyway. But I'm not going to do it tonight because I'm pretty sure the scene is going to. So, yeah, now we're getting down to 5.1 miles per hour, but even 5 minutes unguided shouldn't be too bad. Now, for our final target, we're definitely going to do that through the luminance filter. And that's a spectacular target. So we're going to hopefully end on a good one. We've done this one before and had good results. And we've done the next one before too. But we'll see how it goes.
Let's all think good thoughts.
Yeah. Sometimes it's hit or miss with astronomy. See, somebody on YouTube asked, when is the next public night at Owl Observatory, which is our observatory at the Kalamazoo Nature Center? We begin our next season in April. The schedule is technically on our website now, but it hasn't officially been confirmed by the Nature Center. And usually they never object to any of the dates because they take place so late at night. It doesn't really interfere with anything. But yeah, we start up the public nights in April. All right, that looks a little better. We'll see how the stars are as soon as it does the plate solving. After we officially wrap up the session here, I think I might go back and image a couple of those targets tonight, including this one, just to see how the guider does. All right, I think we're all done. Are we ready? Here we go, M78, finally. That's pretty good.
Well, all right.
That's really beautiful.
And that's unguided too.
Very nice, Richard, very nice.
That's pretty good for unguided.
Looks great. Looks great.
scroll down there a bit. Here,
Is that a variable nebula?
no, this is not a variable nebula like Hubble's variable nebula. This is a reflection nebula. All right, so small telescopes reveal the two illuminating stars, which appear like a double nucleus in the compact coma or head of a, like a comet. The nebula fans out to the southwest and suggests a faint comet tail. As I mentioned, this is part of the larger Orion Nebula complex with M42, M43 as its most prominent members. With an area of 8 by 6 arc minutes, it corresponds to a linear diameter of 10 light years. So I believe that concerns the whole region, is 10 light years across. M78 hosts a large number of very young stars, less than 1 million years old, most of which have not even reached the main sequence yet. And stars, spend 90% of their lifetime on the main sequence, which means they fuse hydrogen into helium in their core. So these young stars include 45 variable T Tauri stars, 17 Herbig-Haro objects that have jets of matter ejected from young stars, and in 1991, infrared observations with the 1.3 meter Kick Peak telescope discovered 4 star clusters totally hidden in visual light by these dark obscuring clouds. So there's a lot more there, but the dust blocks our view. So there we go. M78, the other Orion Nebula, finally. After number 1, I did a bonehead move and did it in H alpha, which was dumb. I don't know why I did that. If Pete were here, if Pete were here, he would have been like, Richard, why are you doing this in H alpha? But no, he's not here tonight to stop me from doing something dumb. So sometimes I got brain farts, but hey, that looks pretty good. That was worth the wait. All right, let me set up our. Yes.
Yeah, what was the object below
that was,
M78?
I believe that was also part of M78.
Oh, really?
I don't think it's a separate object. I might be wrong on that. So it wouldn't
okay, you
surprise
had
me.
mentioned a couple of other things that might show up, and
I don't. It could be, but
okay.
but I don't think so.
Okay, thanks.
Yep. So someone can verify that for me. All right, we'll do 5 minutes for this one because it is very bright. We'll do NGC 1977. So NGC 1977 is one of my favorites, the Running Man Nebula. This is the northernmost part of Orion's sword, lying 0.6 degrees north of the Orion Nebula. So it's very close to the Orion Nebula. Sharpless 279 is another designation. It's an emission nebula that includes a reflection nebula known as the Running Man Nebula. Sharpless 2-279 comprises 3 NGC nebulae, NGC 1973, NGC 1975, and the one we're doing, NGC 1977. And they're all divided by dark nebulous regions. But we should be so close in this one that only the Running Man Nebula will be visible. This was discovered by William Herschel in 1786 using a 18.7-inch f13 speculum reflector, which speculum, by the way, is an alloy of tin and copper. It has half the reflectivity of a modern illuminized mirror. So his 18.7-inch was more like a 9.35-inch Newtonian. So this nebula is easy to see in small telescopes, but the Running Man, the dark lane area, is difficult to pick out visually. But with the 20-inch, with a 5-minute exposure like this under dark skies, it's going to look awesome. So sometimes we do the really bright visual stuff that you could observe with an image because it's just so awesome. So it does look like we're pointed right at the Orion Nebula there, but technically we are, but it's the nebula above the Orion Nebula, but it's all part of the same complex. We should get part of the open cluster NGC 1981 in there, but we're looking right up there. So there's the Orion Nebula, the big bright parts here. M43, the head is there, but we're going to look just above that, just out of the field of view. So we won't really see the Orion Nebula in the image, but we'll get a big close-up of the Running Man Nebula. And this thing looks pretty cool through the 20-inch. All right, let's see if we're in better shape with a guide star this time. Well, we sure are. A little rough there at first, but it's gotten better. No questions in the chat there, so we're just getting started. We'll hop around here a bit again. There's the current sky. Oops, someone has a bright light over there. Oh my goodness. That's not too bad though. Looking pretty good. One of these days, I'm telling you, we're going to get a bright meteor going zip. No, we never do. Let's check out the oh, it picked a pretty bright star this time. And the wind's down to 3.8 miles per hour. That's probably why the guiding settled. So 3.8 is pretty good for the big scope. That's where we want it. The star looks pretty steady. All right, then we'll wrap things up here. Back while we're waiting, why don't we go ahead and do the closing slides here? Let me select a few things. I'm just going to throw everything into the chat at once to make life a little simpler. There we go. We'll put it all on there at once. Okay, so while we're waiting for the final image here, you can join the Kalamazoo Astronomical Society and learn to use the remote telescope all by yourself. We do not open it up to members nation or worldwide because we frankly don't have the volunteer support or willingness to make this any kind of a thing approaching a commercial project. So we do keep it local. So if you do live in one of the counties in red here, you can join the Kalamazoo Astronomical Society and use a remote telescope for your own private imaging or research purposes. It's only $50 a year plus your regular membership fee. So compared to a commercial telescope, it is an absolute steal, which is also why we don't open it up to outside places. So be sure to join us for our final online viewing session of the season, which, if all goes well, will be on February 22nd. If clouds or wind or maybe really bad seeing delay us, we'll move the final session to March 1st, right before the end of daylight saving, or the start of daylight saving time. In fact, I think next season, we're going to make 9 p.m. the start time for the entire season, just to make it simple. If you ever think we should do one in March, let me know. But in March after daylight time starts, we wouldn't be able to begin until 10 o'clock. But that would allow us to do some of the spring objects we normally can't do during our regular November to February time period. So I put the registration link in the chat, so you can register right now. But if you are a Kalamazoo Astronomical Society member, you will already get a registration link in your email. But if you're not a member, you can join the online viewing session email list. There are many ways to join. You can grab your phone, scan this QR code, and fill out the form. I put a link to the form in the chat, or you can just send us an email at kas@kasonline.org, or use our contact page and just ask us to add you to the list, and I would be happy to do that. So with the online viewing session email list, you really only get maybe 4 or 5 emails per year. That's it. We don't send out, weekly emails about all things KAS, just really mainly about the online viewing sessions that run from November to February. And be sure you do join us for our February general meeting, we got a very important speaker, Dr. Jonathan McDowell from the Harvard-Smithsonian Center for Astrophysics. We'll be talking about the mega constellations like Starlink that is now kind of taking over the sky and flooding it with just, thousands and thousands of small satellites that cause all kinds of headaches for both amateur and professional astronomers. So learn more about its impacts on astronomy in the future. And of course, you'll be able to download tonight's images at this link. I did put it in the chat. And if you are a member or on the email list, you already have this link in your email about this viewing session. So again, if you are a member or already on the email list, you don't really have to do anything with this. But if you are not, make sure you copy this and save it, because maybe tomorrow or Monday, you can download the images that we took here tonight. All right. And in the background, I heard our final image is done. So let's go and check it out. Yep, we're all done there. Are we ready for the final image of the night? Here we go.
Yep.
Oh, the stars look a little funky.
Nice.
Oh,
That's
boom.
really
It's still nice, Richard. It looks good.
Yeah,
It
I
is.
think so.
Very
Yeah, you
nice.
got the dust lanes out.
Well, we'll replace. We're gonna replace this image too. Cause what happened? That looks like it got a little skippy there again. Oh well. Well, it's been a rough night. So, like the Orion Nebula, the Running Man is associated with the Orion's giant molecular cloud, as I mentioned a few times. The nebula is likely excited by 42 Orionis, a B1V, or main sequence star, in NGC 1977. It appears as a 4.6 magnitude star, 3.8 arc minutes from the center. The star has a mass 12 times that of the sun, with a surface temperature of 25,400 Kelvin, and it is in fact a triple star system. The primary two component has two companions. And again, this is part of the much larger Orion, part of the much larger nebula known as the Orion Molecular Cloud Complex that extends throughout the constellation Orion. It includes Barnard's Loop, the Horsehead Nebula, the Orion Nebula, which includes M42 and M43, M78, and the Flame Nebula, which we might do that one next month because that's a good one too. So there we go. Not quite the big, beautiful finale I was hoping for, but hey, it still looks pretty good.
Thanks, Richard.
So again, thank you to everyone for joining us this evening. Vaccine and wind and all. And we'll hopefully see you at the February general meeting for our very important speaker. But if not, be sure to join us for the February online viewing session. So thanks again for attending.